Good morning, students. Welcome back to this algorithm class again. In this class, we are going to see yet another example problem for dynamic programming. In the last class, we discussed about multi-stage graph problem. There we found the shortest path from the source to the sink vertex. You know the characteristics of a multi-stage graph. Okay, we solved two examples. Okay, recall whatever we have done and also recall what is this dynamic programming is. So here also the solutions are taken in the sequence of decisions based on some sequence of decisions. Now in this class we are going to discuss about another problem, all pairs shortest path problem. All pairs shortest all pairs shortest path problem. Okay, this is also a problem involving graphs. Here we are trying to find the shortest path from every vertex to every other vertex in the graph. That is the problem. It is not simply finding the shortest path from one vertex to the remaining vertices. Rather, it is the problem of finding the shortest path from every vertex of the graph to every other vertex. That is what this problem is. Now let us describe this problem description. So you are given a graph G with a set of vertices and a set of edges. Okay. And also this it is a direct graph and also a weighted graph. Every edge is given a weight value. And let us assume that this graph is made up of n vertices. Then you know that every weighted graph is having a cost matrix. The cost matrix gives you the weight of all edges of the given graph. So we call C is the cost adjacency matrix of the given graph. And you know that the cost between a vertex to the same vertex I, from vertex I to the same vertex I is 0. And also the cost of I comma j is the length of the edge I comma j, length of the edge I comma j of the graph if I comma j belonging to the edge set. And also this C of I comma j is infinity if this I comma j, the edge I comma j doesn't belong to E of G, doesn't belong to E of G. Okay, here I make a correction here. Does not belong to E of G. Then the all pair shortest problem is to determine the matrix A such that A of I comma j is the length of the shortest path from I to j, where the value of I will take all the n vertices, index of all the n vertices. Similarly, the value of j will take the index of all n vertices. Students, I want you to assure you that this is a very simple problem, easy to solve. If this problem is asked in the examination, it is easy to solve and it is quite interesting to solve also. So the problem is not so difficult. Okay, now method of solution. Method of solution. Okay. First we take two vertices. Okay, let us take I comma j is shortest path between I and j. Let us take this is the shortest path between vertex I and j. Let us take. Then, when do you call this one is the shortest path? When do you call this one? Supposing the path I comma j may pass through directly from I comma j, or if it is necessary, it may pass through some intermediate vertices. There might be one intermediate vertex or many vertices. Let us take if k is a intermediate vertex in the I comma j path, then this I comma k is shortest path between I comma k and then k comma j is the shortest path between k comma j. Okay, between the vertex k and j. Between rather I can put it like this: between vertices I and k, and k comma j is the shortest path between vertices k and j. K and j. If this condition is not satisfied, then you cannot claim this I comma j is a shortest path. So our aim is to find the intermediate vertex k with the greatest index, such that this I comma k is the shortest path and k comma j is the shortest path. That is the idea behind this. So we are taking the decision on finding the k, intermediate vertex k. Then once such a intermediate vertex k is found, then the shortest path between the vertex I and k is found. Similarly, the shortest path between k and j is found. Then we try to find another intermediate vertex, if at all it is there, maybe k1, such that the path from I to k1 passing through k is the shortest path from I to k1, and similarly the path from k1 to j is the shortest path between the vertices k1 and j. Once such a k1 is found, then we will try to find another k2 like this. It will go on. We will take subsequent decisions. Okay. So that is the way we are approaching this problem. Okay. So as in the case of multi-stage graph, in this shortest path problem also, we have a recurrence relation that helps us to improve the shortest path from one stage to the next stage. Okay, so what is the recurrence relation? This is the recurrence relation. The recurrence relation to solve this problem. Solve this problem is ak of I comma j is equal to minimum of a of k minus 1 comma I comma j comma a of k minus 1 comma of I comma k plus a of k minus 1 comma k comma j, where what is this k? K is a stages. Whereas k is a stages, intermediate stages. So initially, if you are given a vertex graph of graph of three vertices means, then k will take the value of 1, 2, 3. Okay, so when k takes the value of 1, that is a of I comma j, we find minimum of a of 1 minus 1, 0, a of 0 comma I comma j plus a of 1 minus 1, a of 0 comma I comma k plus uh, a of 0 comma k comma j. That is the one we are finding. Okay, so the next shortest path is found from the previous stage. Okay, the algorithm that solves this problem is given now. Okay, so this is the algorithm that solves this problem. Okay, algorithm, you see, in this algorithm you see name of the algorithm is all paths, where a is the c is the cost matrix, n is the uh, number of vertices, a is the stage at which we are improving the shortest path. Okay, so initially I said a of I comma j is equal to cost matrix of the given graph. Then for k is equal to 1 to n, then for j I is equal to 1 to n, then for j is equal to 1 to n, I do this a of I comma j equal to minimum of a of I comma j comma a of I comma k plus a of k comma j. Okay, so when we solve one problem, you will find that this problem is very easy to solve, and this recurrence relation can be used very easily to solve this problem. Okay, so we try to solve one example problem. I give you one example problem. Okay. See, this is the graph in which we have to find the shortest path between the given three vertices. What are they? Vertex 1, vertex 2, vertex 3. Okay, there are some edges that are going directly from one vertex to another vertex, and there are some edges, there are some sequence of edges connecting two vertices. Now, if you are given such a graph here, first of all, you should write the cost matrix of the given graph. What is the cost matrix? How many vertices are here? 1, 2, 3. 1, 2, 3. Similarly, row wise 1, 2, 3. Now, so this is vertex 1, vertex 1. Then what is the cost value between the same vertices, vertex 1 and 1? See, that is 0 always. So the shortest distance between the vertex to the same vertex is 0. Similarly, the shortest vertex from vertex 2 to itself is 0. Shortest vertex from vertex 3 to itself is 0. Okay. Now, what is the short from this matrix? There is a edge from vertex 1 to vertex 2. What is the value? 4. So vertex 1 to vertex 2 is, the value is 4. Then vertex 1 to vertex 3, we have a edge, the value is 11. So 1 to 3, it is 11. Then 2 to 3, we have a edge, the value is 3. So 2 to 3, 2. Then 2 to 1, yes, we have a edge, the value is 6. 2 to 1 is 6 here. Similarly, 3 to 1. 3 to 1, we have a edge, the value is 3. And 3 to 2, there is no edge. So edge is coming from vertex 2 to vertex 3 only, but no edge is coming from vertex 3 to vertex 2. So in this case, you put that as infinity. This is infinity. So the shortest path between vertex 3 to itself is 0. So this is the cost matrix of this graph. This is the cost matrix of this graph. Okay, so I write it like this now. I create a 4 by 4 matrix. And this is A naught. A naught of A naught of I comma j. So the what are the vertex values? 1, 2, 3. Similarly, vertex values are 1, 2, 3. 3. I put them as red marks. These are the vertices. Okay. Now what is the from the between A of 1 comma 1, it is 0. Sorry, it is 0. A of 2 comma 2, it is 0. A of 3 comma 3, it is 0. Then 1 to 2, it is 4. It is 4. Then 1 to 3, it is 11. Then 2 to 1, it is 6. And 2 to 3, it is 2. Then 3 to 1, it is 3. 3 to 2, it is infinity. I simply mark it as I have a symbol here, infinity. Yes, okay, this I put it here. It is infinity. So this is the initial stage. Now I have to solve this problem. How many vertices are here? 3 vertices are here. So I have to solve it for a 1 of I comma j. From this, I go for a 2 of I comma j. From here, I go for a 3 of I comma j. From here, I go for a 3 of I comma j. Okay. Okay. Now these are all k values. These are all k values. Okay. These are all k values. Now, where is this a1 of I comma j? It has to be found from our comma j. From here we have to find this one. Now, where is this a0 of I comma j is available? It is available here. This is our this one. Okay. So my k will take the value of 1 comma 2 comma 3. Then when k is equal to 1, when k is equal to 1, uh, then my j will take the value of 1. Then I have to do this problem for I is equal to 1 comma 2 comma 3. Okay. Then sorry, it is I. It is I and it is j. It is j. I have to solve this one. So okay. Similarly, when k is equal to when k is equal to 2, I have to solve this one for my I will take the value of 2. My I will take the value of 2. Then I have to solve this again for 1 comma 2 comma 3. Then similarly, when k is equal to 3, my I will take the value of 3, my j will vary from 1 comma 2 comma 3. Okay. So when I solve this one, that is when I ultimately find what is this a3 of I comma j, a3 of, when I have found out what is this a3 of I comma j, I would have found out the shortest path between every vertex to every vertex to every other vertex. That is what my aim is. So first we should try to find what is this a1 of I comma j, a1 of I comma j. That is we solve this one for, I copy this one. Now this one is 1 and these are these are the values I have to find. These are the values I have to find. Okay, I mark them as okay. Because this A11 of A11 of A of 1 comma 1 is 0, A of 2 comma 2 is 0, A of 3 comma 3 is 0, for whatever be the value of k, it is the same. So we have to find what is this A of 1 comma 2 for this A1 of I comma j. Okay, so we shall apply this formula. We shall apply this formula here. Okay. We have to apply the formula. Okay. The formula is A of I comma j equal to minimum of A of I comma j plus I comma j I comma j comma A of I comma k plus A of k comma j. That is the formula. So that is the formula. A of I comma j is equal to minimum of A of I comma j plus A of I comma k plus k comma j, that we have to find. Now this is the formula. So what is my k value? K is equal to k is equal to 1. Let us start with I is equal to 1. I is equal to 1. So then when k is equal to 1, I is equal to 1, then j is equal to 1. So what is this? A of I comma j, a of I comma j, a of I comma j, that is a of 1 comma 1, a of 1 comma 1, a of 1 comma 1 is equal to minimum of a of 1 comma 1 comma 1, because the value of I is equal to 1, value of I is equal to 1, j is equal to 1. Then so j will okay, then comma a of I comma k, I is equal to 1 comma k is equal to 1 plus a of k comma j, k is equal to 1 comma j is equal to 1, j is equal to 1. See, this we need not have to find, this we need not have to find, because in every iteration this a of 1 comma 1, a of 2 comma 2, a of 3 comma 3 will be 0. So here also, why I am doing this, I want you to know this. So it is minimum of a of 1 comma 1, a of 1 comma 1 is 0, so it is 0 comma again a of 1 comma 1 is 0 plus 0. Okay, so what is the value? It is minimum is 0. So you don't have to find this a of 1 comma 1, a of 2 comma 2, a of 3 comma 3. Straight away you mark them as 0. I mark them as 0. Okay, this has been found out. This has been found out. Now I am going to find what is this a of 1 comma 2. A of 1 comma 2. A of with I is equal to 1, j will vary from 1 comma 2 comma 3. So j is equal to 1, we have taken into consideration. This is over. This is over. Now we have to take this j is equal to 2. So a of 1 comma 2. A of, sorry, a of 1 comma 2, because I is equal still 1 only, j is now j takes the value of 2, is equal to minimum of a of I comma j, that is 1 comma 2 comma a of I comma k. I is equal to 1 only, k is equal to 1 only. So 1 comma 1 plus a of k comma j, k is equal to 1, j is equal to 2 here now, j is equal to 2 here, j is equal to 2 here. Now we compute these values. It is equal to minimum of, what is this? What is this? A of 1 comma 2, a of 1 comma 2 here. This is a of 1 comma 2. A of 1 comma 2 is equal to 1, 2. It is 4. So it is 4 comma, then a of 1 comma 1 is 0, that we know already, plus a of 1 comma 2, a of 1 comma 2, from here 1 comma 2 it is 4, So it is 4. Okay. Now what is the minimum value? 4 comma 4, that is equal to 4 only. So now we have found what is this a of 1 comma a1 of 1 comma 2, that is 4. It is 4. It has been found out. Now next I is equal to 1, j is equal to 1 is found, I is equal to 1, j is equal to 2 is found. Next I compute what is this a of 1 comma 3, a of 1 comma j takes the value of, so it is minimum of, what is the formula? A of I comma j, I is equal to 1, j is equal to 3, comma a of I comma k, I is equal to 1, j is equal, k is equal to 1, I comma k, plus a of k comma j, k is equal to 1, j is equal to 3, j is equal to 3. So this is equal to, you supply the value now, minimum of a of 1 3. So a naught of 1 comma 3, a naught of a0 of 1 comma 3, it is 11. So it is minimum of 11 comma, a of this 1 comma 1 is 0, plus a of 1 comma 3, again it is 11 only. Okay, so that is equal to, so the minimum value is equal to minimum of 11 comma 11 is equal to 11. So a of 1 comma 3, it is also found out 11. So with I is equal to 1, j is equal to 1, 2, 3, these values are found. Okay, now so this iteration is found out. This iteration is found out. Now I go for, still k is equal to 1. Now I is equal to 1 has been found out. Now I is equal to 2. Again j will vary from 1 comma 2 comma 3, 1 comma 2 comma 3. So now my values are a of I comma j, I is equal to 2. So 2 comma 1 equal to minimum of a of I comma j 2 comma 1 plus comma a of I comma j. So 2 comma 1 plus k comma j plus a of k is equal to 1, k comma j, j is equal to 1, j is equal to 1. Okay. Now this is equal to minimum of a of 2 comma 1, a naught of 2 comma 1, a0 of 2 comma 1 is 6 only. So it is 6 comma a of 2 comma 1, again it is 6 comma 6 plus a of 1 comma 1 0. So it is equal to minimum of 6 comma 6, it is equal to 6 only. So it is 6 only. So with I is equal to 2, this has been found out. The minimum value of a of 2 comma 1 is also found out, that is equal to 6. That is equal to 6. Then I is equal to, then j will take the value of 2. So a of 2 comma 2. So that I am not going to found, because you know that it is 0 only. The minimum path from the vertex to the same vertex is 0 only. So that is why I already marked it as 0. So this has been found out. This has been found out so far when k is equal to 1. So this is also found out. Now j will take the I is equal to 2, j takes the value of 1, 2. Now j takes the value of 3. So a of 2 comma 3 equal to minimum of uh, a of I comma j. I is equal to 2, j is equal to 3, comma a of I comma k. I is equal to 2, k is equal to 1 plus k comma j. A of k is equal to 1, j is equal to 3. J is equal to 3 now here. So j is equal to 3. So that is equal to, we have to find. So minimum of, what is a naught of 2 comma 3? A naught of 2 comma 3, it is 3, 2. So it is 2 comma, a of 2 comma 1, a naught of 2 comma 1, it is 6. 6 plus a naught of 1 comma 3, a naught of 1 comma 3, 11. So 11, that is equal to minimum of, so it will be 6 comma 2 comma 17. So which is minimum? 2 is minimum. So the value is 2. So a of 2 comma 3 is equal to 2. A of 2 comma 3 is equal to 2. So this is also has been found out. This also has been found out. Now I is equal to 1 has been found out, I is equal to 2 has been found out. Now still my k is equal to 1. Now my I equal to 3, because there are 3 vertices, the last vertex is 3. Now for this one, j will vary from 1 comma 2 comma 3. J will vary from 1 comma 2 comma 3. So that we will do it now. Okay, so a of I comma j. So a of I comma j, I is equal to 3, So 3 comma j is equal to 1. J will vary from 1. A of 3 comma 1 is equal to minimum of a of I comma j. I is equal to 3, j is equal to 1 plus comma a of I comma k. I is equal to 3, k is equal to 1 plus k comma j. A of k is equal to 1, j is equal to 1. J is equal to 1. Okay, so this is equal to a of 3 comma 1. A of 3 comma 1 in this area it is 3. So minimum of 3 comma, again 3 comma 1 is 3 plus 0. 3 plus 0. So that is equal to 3. A of 3 comma 1 is equal to j is equal to 1 has been found out. So a of 3 comma 1 is equal to 3. So it is 3. It is 3. Now, so it is also found out. It is also found out. Next, j takes the value of 2. So a of 3 comma 2. 3 comma 2 equal to minimum of a of 3 comma 2 comma a of I comma j, I comma k. So I is equal to 3. So k is equal to 1 plus k comma j. A of k is equal to 1, j is equal to j is equal to 2. J is equal to 2. That is equal to minimum of a of 2 a naught of 3 comma 2, a naught of 3 comma 2, it is infinity. So a of 3 comma 2 is infinity inf comma a of 3 comma 1, a naught of 3 comma 1, a naught of 3 comma 1 is 3, a naught of 3 comma 1 is 3 plus a of 1, a naught of 1 comma 2, 1 comma 2, it is 4. So it is 4. So this is equal to, which is minimum, infinity comma 3 plus 4, 7. So 7 is the minimum. So a of 3 comma 2 is equal to 7. A of 3 comma 2 is equal to 7. So 3 comma 2 is equal to 7. So this is also found out. Then it becomes a of 3 comma 3. So you know that it is 0 only. It is 0 only. So this is also found out. So with k is equal to 1, everything has been found out. Next, what we have to do? Then k is equal to 2. Then I will take the value of 1. Then for this I, what is the value of j? J will take the value of 1 comma 2 comma 3. That we have to find. Okay, that we will do it in the next class. Okay, we will see, we'll resume this solving in the next class.